okay, it would get rid of the square root, right? So we can divide the 2 over. And then we do a square. Okay, or you can just square throughout the whole equation, that is also fine. Okay? So then after upon expansion, you will get x squared minus 4x minus 4. Okay? 8 plus 4, right? Yeah. Okay, so x squared minus 4x plus 4 over 4 equals to x squared minus 4x plus 1. And then you can proceed to solve as per your natural ability by now, I hope. Natural ability. 3x squared minus 12x. Okay? Then we get 3x squared minus 12x equals to 0. Okay? Some of you might be getting instead 3x squared equals to 12x. Then you happily divide x over, and then divide by x across. Can we actually divide by x across like that as per what we want? Okay? Always remember that x is a variable. As long as the question did not specify that x cannot be equals to 0, okay, we should not assume that we can divide by x. Because if x were to be 0, we cannot do the division. Okay, we cannot divide by 0. Alright, so in this case, we should not just go about dividing a variable across. Okay, so what you should do is to factorize x out, or rather factorize out maybe 3x. So you find x equals to 0 or x equals to 4. However, just now Noel pointed out that with x equals to 0, you will find that the derivative, okay, gives you a value of negative 2. Which is not consistent with the question. Okay, so therefore we reject x equals to 0. Yep. So I can't hear you. Yeah, I use the original gradient one. This one? What do you mean by substituting into original? But then we will be finding y value, right? But what I'm pointing out is that if x equals to 0, the gradient of the tangent of this curve, okay, at this particular point now x equals to 0, the gradient is going to be negative 2. But the question says that the gradient is 2, positive 2. So that's why it is inconsistent. Okay, that's why we must reject x equals to 0. Okay, yes. Okay, just write it down. Right, so therefore, then after when x equals to 4, in this case, we do get your derivative to be equals to negative 2. Usually, by right, this shouldn't happen. Okay, I think it is must have been overlooked, oversight by the question, by the textbook. Okay, so when x equals to 4, so I'm trying to say that usually you need not actually check the derivative, okay, but it is a good practice. You got another lesson now. Oh, wow, okay. So, y is equals to, and now you substitute, okay? Y equals to 1. Okay, so therefore, the coordinates will be 4, 1. Okay? Yeah, so I say it's an oversight by the textbook law. Okay? Yes. In this particular case, yes. Okay, but usually in exam, the question will not have this kind of law. Yes. Okay, thank you class. Thank you everyone. Thank you and goodbye, Miss Mom. Have a nice day and Miss Agnes. You too. I don't know, I thought outside. She said Monday, right? Oh, you should really pass the good. Stop.